Hello everyone, very good morning. I welcome you all at India's most comprehensive preparation platform for all competitive exams, that is BYJU'S exam prep. So guys, today we are going to discuss few more questions of the chapter graph theory of discrete mathematics. We have already done some of the questions of graph theory. Now let's look at few more related to some other concepts. So this is brief introduction of myself. My name is Vishal Rawatiya. I have 10 plus years of teaching experience and following are the achievements and areas of expertise. This is my Telegram group. If you guys have any doubt related to GATE preparation, whether it is CS paper or DA paper, then you can ask at this particular Telegram group and I'll be happy to resolve your queries. Okay. BYJU'S exam prep is going to conduct a national scholarship test today between 9 a.m. to 9 p.m. Do participate in this particular test, and if you perform good, you may avail up to 90% off on all our programs. Dheeraj Sadhana sir is going to conduct a workshop on 18th of October at 7:30 p.m. In that particular workshop, the sir is going to discuss the thing which is mostly troubling the GATE 2025 aspirants, that what is the correct time to start preparing for the GATE exam. So if you want to know that what exactly is the right time for start preparing for the GATE 2025, then this workshop is for you. You guys can attend this workshop simply by downloading the app and registering on the app using your mobile number. It's absolutely free. Okay, so there's a big announcement that BYJU'S exam prep has started the mega mock test series. So this is the timeline for that particular series. You all can observe that at which particular date, at what time the test will be conducted for which particular subject. So there are some subject-wise tests, there are some full-length tests, and there are some lengthy tests. So please go through all this. You guys can go through this detail and you guys can choose to analyze your preparation by participating in this particular test. Okay, so now yes, this is a high time that you guys actually start giving the test, guys, because it's very much important that you evaluate your preparation, because it is the time when you finally need to evaluate it and you need to push all your efforts to enhance your preparation, right? So please, for the participation in the test, the link is available in the description. You can download it from there. Okay, now apart from that, BYJU'S exam prep team has announced a crash course for GATE computer science aspirants. You guys can connect on this number. Let me write it. I believe it may not be visible to you. So 9241 33 333 So you guys can contact on this number if any one of you want to join this crash course which is being conducted by the BYJU'S exam prep team for computer science aspirant. Okay, so let's start with the today's session. So this is the very first question. Now, in a connected graph, a bridge is an edge whose removal disconnects the graph. Yes, we all know that it is known as edge connectivity. Now, or cut edge. Which one of the following statement is true? Let's assume that G1 is a graph in which the set of vertices is V, but the set of edges is even. G2 is another graph with the same set of vertices V, but the set of edges are different. So basically, G1 and G2 are two graphs which are having exact same set of vertices, but the edges may not be same. So some of them may be same, some of them may be different. That's just two random sets, E1 and E2. Now, it is also given that both G1 and G2 are connected graphs. Okay, they are connected. G1 and G2 are connected. Now, with more than two vertices, it's okay. Now, if you take the intersection of G1 and G2, that is, what will happen? Sir, intersection. So, vertices are common, but the edges may not be, all the edges may not be common. So, the idea is when you take the intersection of two graphs G1 and G2, then you will get the same set of vertices, but the edges in that intersection of G1 and G2 will be only the edges which are common in G1 and G2. So it will be intersection of the edges of G1 and G2. Now it is being said that this intersection is not a connected graph. So G1 and G2 are given as connected, but the intersection of G1 and G2 is given as that it is not connected. Now they are asking, then the graph, if we take the union of those two graphs, G1 and G2, then ultimately it will be this graph with the same set of vertices, but this time the edges of G1 and G2 will be unioned. Means if an edge is present in any one of the graph G1 or G2, it will be present in G1 union G2. Now it is asking certain things related to this particular union of two graphs G1 and G2. So please tell me, it cannot have a cut vertex, must have a cycle, must have a cut edge, that is a bridge, which is defined here. Cut vertex is what? Sir, cut vertex is a vertex. So what does it say? In a connected graph, bridge is an edge whose removal will disconnect the graph. Cut vertex is a vertex whose removal can disconnect the graph. So please try to understand. Now, it is very important fact. No, Manish. It is very important fact that if cut edge exists in a graph, then at least one of the vertex associated with that particular edge will also be a cut vertex. So existence of cut edge or bridge will imply the existence of cut vertex in the graph. But if a cut vertex exists in the graph, then it is not necessary that cut edge will also exist. Okay. Anyway, so please try to understand. These are some points, and this is a question related to analysis. This is a question related to analysis. You cannot simply go and start applying some formulas and can obtain the answer of this particular question. So you need to visualize that what is actually happening. So there are two graphs G1 and G2. Now you need to think of two graphs. You need to think of two graphs such that those two graphs are connected on the same set of vertices, but you also need to ensure that when you take the intersection of those two graphs, it must be disconnected, right? So what I can observe, it is the same question. I have just removed the option. Let's think of this graph. Please try to understand. I'm just trying to visualize that, okay, this is one graph, it is connected. Yes, it is connected. But I need to make sure that the intersection is disconnected. Let's assume that this is your graph G1. Let's think of this, that this is your graph G1, whereas this is your graph G2. Both G1 and G2 are connected? Yes, sir. G1 and G2 are connected. If I take the intersection of G1 and G2, what will happen? So intersection of G1 and G2, this edge is common, as well as these two edges are common. So this is intersection of G1 and G2. So do you realize that yes, this may be a graph corresponding to this problem in which G1 is connected, G2 is connected, G1 and G2 are on the same set of vertices, the set of edges may be different. Now, when we are observing the intersection of G1 and G2, then obviously intersection of G1 and G2 is disconnected. Please try to understand. This is an edge which is present in both the graph G1 and G2, therefore it is present. These two are the edges which are present in both the graphs, therefore it is also, and those two edges will also be present in the intersection. Now, when we take the union, you all can realize that the union will be something like this. Union can be something like this, right? So this is G1 union with G2. I'll give you an explanation that why have I considered this particular edge, but please try to understand. Now think of it. Now it is saying that in G1 union G2, certain things are being asked. Cannot have a cut vertex. Does it have a cut vertex? Can it have a cut vertex? Please try to understand. In G1 union G2, this is a vertex which is a cut vertex. Yes or no? This is a vertex which is a cut vertex. If we remove this particular vertex from the graph, then the graph G1 union G2 will become disconnected. Yes or no? So cannot have a cut vertex is obviously a wrong answer. And that's the reason I have included this particular edge, because if I don't include this, then this particular edge will not be visible and you will think that there is no cut vertex. There is no cut vertex. Now, another thing is must have a cycle. Yes, this is necessary. This is necessary. Let me tell you why. Because when we are saying that the graph G1 and G2 are connected. Graph G1 and G2 are connected, and when we are taking the intersection of these two, then it is disconnected. Means there are two vertices. Let's assume this is your vertex X and this is your vertex Y. This is your vertex X and this is your vertex Y. In G1 and G2, if X and Y are disconnected, in G1 and G2, if X and Y are disconnected, then the path, listen to me carefully, then the path between X and Y in graph G1 and the path between X and Y in G2 must be disjoint, because if the path between X and Y in G1 and G2 is common, then that path will also be present in G1 intersection G2 and X and Y will again become connected. X and Y will again become connected. So that's the idea. If there are two vertices X and Y such that they are not connected in G1 intersection G2, but they are connected in G1 and G2, then there must be two disjoint paths between X and Y. There must be a separate path between X and Y in G1. There must be a separate path between X and Y in G2. Now please try to understand. If we will take the union of G1 and G2, then both those paths will appear in G1 and G1 union G2. Now, if there are two paths between two vertices, of a graph, then there must be a cycle. Please try to understand. Let's take a simple cycle. In cycle, between every pair of vertices, there are two different paths. Clear? One you can choose. Let's assume this is your X, this is your Y. Then this is one path and this is another path. So if there are two paths between a pair of vertices, then definitely there will be a cycle, right? And that's what I'm saying, that if G1 intersection G2 is disconnected and G1 and G2 are connected, then there will be two vertices X and Y such that the path between X and Y in G1 will be disjoint from the path between X and Y in G2. If this is the case, then when we take the union of these two, the union of G1 and G2 will consist of a cycle. Clear or not? Is it clear that it must have a cycle? This is the observation which you need to understand. There are certain things. G1 union G2 must have a cycle. Clear? Now, must have a cut edge. Please try to understand these two statements are must have. Now, it is saying that must have a cut edge. In this particular example, cut edge may be present. But my idea is, even if I remove these two things, even if I remove this, then also everything else given in the statement is correct. Apart from cut vertex, if I do not consider this particular edge that we were earlier considering, if we do not consider that edge, then there will be no cut vertex. But in the question it is saying that cannot have a cut edge. No, it may have a cut vertex. It may be the case that cut vertex and cut edge are not present simultaneously. It may be the case that cut edge and cut vertices are not present simultaneously. But yes, some of the graphs which are satisfying this property may have cut vertex. Therefore, the statement that they cannot have a cut vertex is obviously wrong. When they are saying must have a cut edge, this is also wrong, because in this case, if we consider this as G1, if we consider this as G2, then this will be G1 intersection G2. G1 is connected, G2 is connected, G1 intersection G2 is disconnected, and G1 union G2 is connected, but there is no cut edge in the graph G1 union G2. Therefore, this statement that must have a cut edge is also false. Clear? Now they are saying has a chromatic number strictly greater than those of G1 and G2. Come on, this is also not true. What is the chromatic number of this graph? So the chromatic number of G1 is 2. Chromatic number of G2 is also 2. Chromatic number of G1 union G2 is also 2. So it may be equal. Why are you saying that it must be strictly greater? Strictly greater means it cannot be equal to the chromatic number of G1 or G2. Manish, clear? The chromatic number of the graph may be equal to the chromatic numbers of G1 or G2. It need not be strictly greater than the chromatic number of G1 and G2. Clear? So that's the idea. Correct answer will be cycle. The simple logic is that there are two distinct paths between two vertices X and Y. When you take the union, both of them will be available in the union of G1 and G2. Therefore, there will be a cycle in G1 union G2. Now, let's look at the next question. The 2 raised power n vertices of a graph G. So, how many vertices in the graph G? So, 2 raised power n vertices. From where are we deriving these vertices? 2 raised power n vertices of graph G correspond to all subsets of a set of size n. So, if there is a set of size n, there will be exactly 2 raised power n subsets of the set of size n, and each one of those subsets will represent the label of the vertex. Each one of those subsets will represent the label of that vertex. Now it is we'll understand why n equals to greater than or equals to 6. Two vertices of G are adjacent. So now how are we representing the vertices? Sir, we are representing the vertices using the subsets of a set of size n. Now two vertices are adjacent if and only if the corresponding sets, if we have a vertex v1 and we have a vertex v2, then there will be a subset of corresponding to v1, there will be a subset corresponding to set v2 if we take the intersection of those two sets. If we take the intersection of those two sets and if the intersection results in exactly two elements, then there will be an edge between them, otherwise there will be no edge between them. Now what is being asked, that the maximum degree of a vertex in G is what? Maximum degree of a vertex in G is what? Please try to understand. Let me explain this. That let's assume that set A is nothing but a set, they are saying, with greater than or equals to 6. So let's simply assume 1, 2, 3, 4, 5, 6. So minimum size. Let's think with the set of minimum size. Now there will be how many subsets? So there will be 2 raised power 6 subsets. That is 64 subsets. That's fine. Now they are asking what will be the degree. Please try to understand. If I take the vertex phi, if I take the set phi, then it can, the intersection of y with no other subset of A can be of size 2, because phi intersection with anything will be phi. Therefore, the degree of phi, if I say the degree of vertex whose label is defined using this empty set, will be 0. Now, if I ask you that, sir, what will be the degree of a set which consists of only one element? So, degree of a set, degree of a vertex whose label is given by a set consisting of only one element will be 0. So, how many such vertices will be there? Sir, if there are n numbers in the set, then degree of 1, degree of 2, degree of 3 up to degree of n, they all will be same and their degree will also be 0, because a set of size 1 can never result in a set of size 2 on intersecting with some other set. So yes, sir, these are the sets of degree 0, but it is asking for the maximum degree in the graph. Now please try to understand. If I have a vertex whose set consists of exactly 2 elements, now my question is that this particular vertex whose label is 1, 2 will intersect or will result in 2 elements with exactly how many subsets of this set? Will result in 2 elements with exactly how many? 2 subsets. How many subsets of this set? Please try to understand. There are exactly 2 elements in this set, that is 1, 2. If you want that intersection also result in exactly 2 elements, then the set with which we are trying to intersect this 1 comma 2 should also consist of 1 comma 2. Now my question is that if let's try to understand 1 comma 2 intersect with 1 comma 2 as long as 1 comma 2 are present and any other element. I hope you understand. If 1 comma 2, if we intersect 1 comma 2 with a set which consists of elements 1 comma 2 and any other element apart from that, will result in 1 comma 2 and the size of 1 comma 2 will be exactly 2. So 1 comma 2 will be adjacent to all other sets which are which consist of elements 1 and 2. Apart from that, there may be any other element present or not present in the set. So sir, if we are definitely choosing 1 and 2, then we can choose 1 only in one way and we can choose 2 only in one way. For remaining elements we have two choices, otherwise either we can take those elements or we can leave them elements. So we can take element 3 or we can leave element 3, therefore two choices, 2 element, 2 element. So sir, apart from these two elements, how many other elements are there if there are exactly n elements in the set? Sir, there will be n minus 2 elements. So this 2 into 2 into 2 will be how many times? It will be n minus 2 times, because we have already chosen two elements 1 and 2. For remaining n minus 2 we have 2 raised power n minus 2 choices. So the degree of a set consisting of two elements will be 2 raised power n minus 2. Please try to understand, in this 2 raised power n minus 2 there will also be a self loop, that is 1 comma 2 intersects with 1 comma 2. Therefore this will also be the case. So that's okay, but I'll explain that in a while. That either you can say that okay, if self loops are not allowed, then the degree will eventually reduce by 1. That is, this 1 comma 2 is not allowed to intersect with 1 comma 2. The 1 comma 2 is not allowed to intersect with 1 comma 2, then in that case it will become this. But let's assume that okay, self loop is also allowed, so it will become 2 raised power n minus 2. Now if there is a vertex whose label consists of 3 elements 1, 2, 3, then what will be the degree? What will be the degree? Please try to understand. If you want to ensure that 1, 2, 3 intersect with exactly two elements when with some other set, then the idea is that exactly two of these three elements should be present. Exactly two of these three elements should be present, and for remaining n minus 3 elements there is no constraint. So sir, we can choose 2 out of these 3 elements in 3C2 ways. So choose exactly 2 out of 3 elements in 3C2 ways, and for remaining n minus 3 elements you will have 2 raised power n minus 3 choices. Therefore it will become 3C2 is 3 into 2 raised power n minus 3. Yes or no? Sir, if there are 4 elements, what will be the degree? 1, 2, 3, 4. Please try to understand. If there are 4 elements, then you need to ensure that exactly 2 of these 4 elements are present in that other subset. So in how many ways we can choose 2 out of 4? Sir, we can choose 2 out of 4 in 4C2 ways. And apart from this 4, if you are choosing 1 and 2, then obviously you are leaving 3 and 4. So only one possibility, that choose 1 and 2, leave 3 and 4. And for remaining n minus 4 elements, you will have 2 raised power n minus 4 possibilities. Sir, 4C2 is 6. 4C2 is 6 into 2 raised power n minus 4. This is exactly same as 3 into 2 raised power n minus 3. So these two values are same. These two values are same. That is, when the degree, please try to understand, when the degree when we are taking a vertex which consists of 3 elements, then the degree of that particular vertex will be 3 into 2 raised power n minus 3. Similarly, if the vertex is a vertex whose label is consisting of 4 elements, the degree of that particular vertex will also be 3 into 2 raised power n minus 3. Now my question is, as you keep increasing this value, what will happen? So degree of 1, 2, 3, 4, 5. Now forget about this, that there may be, the number of elements may be more than 6. So if we talk about degree of a vertex whose set corresponds to, or whose set consists of 4 elements 1, 2, 3, 4, 5, then sir, exactly 2 out of this 5 should be present. Therefore 5C2 exactly 2 out of this 5 should be present, therefore 5c2 into 2 raised power n minus 5. Similarly, for 6 that will be 6c2 into 2 raised power n minus 6. So do you realize that from now on this value is decreasing exponentially and this is only increasing multiplicatively. So exponential decrementation will be less. So from now on the degrees will start reducing. You can actually say 5c2 is what? So 5c2 is 10. So 5c2 is 10. 10 into 2 raised power n minus 5 will be what? Sir, 10 into this will be 2.5 into 2 raised power n minus 3. 2.5 into 2 raised power n minus 3. Yes, sir. So this is 3 into 2 raised power n minus 3, whereas this is 2.5 into 2 raised power n minus 3. Sir, what is this 6c2? It is 15. 15 into 2 raised power n minus 6. So to the 8. So this will be 15 by 8. If I divide it by 8 and multiply it by 8, then this will become 15 by 8 into 2 raised power n minus 3. So I hope you understand that this value will be even lesser than 1. It will be lesser than 2. So that's the idea, that now this value is decreasing exponentially and this is increasing only multiplicatively. So the decrement will be more compared to increment. Therefore, from now on, when the value of when the number of elements in a set are 5 or more than 5, then ultimately the degrees will start reducing. The degree will be maximum. Degree of a vertex will be maximum corresponding to a vertex whose label consists of exactly 3 elements out of this set or exactly 4 elements out of this set. And what will be the degree in that case? So the degree will be 3 into 2 raised power n minus 3. Degree will be 3 into 2 raised power n minus 3. Therefore, this is the most appropriate answer. Clear? Clear? This is just an aptitude but analytical thing, that how to solve this type of problems. Now, I have also told you that there will be some vertices of degree 0. There will be some vertices of degree 0. So the vertices of degree 0 means they are all isolated vertices. So obviously these are isolated components in the graph. So this graph will not be connected. This is for sure, because there are some vertices of degree 0. Therefore this graph cannot be connected. These vertices of degree 0 are isolated vertices. Okay, sir. Let's move to this next question, which is related to concept of Hamiltonian cycle. And basically Hamiltonian cycle, if somehow you can traverse all the vertices of the graph exactly once by leaving some of the edges, then it's a Hamiltonian cycle. Now please try to understand this. Let G be an undirected complete graph. So it's an undirected, so there is no direction. Undirected complete graph. Okay, complete graph on n vertices. Oh, n vertices are there, and so it's basically a kn. Simply call, say kn. It's a complete graph. Now the value of n is greater than or equals to 2, means the complete graph kn such that we are either considering k3, k4, k5, etc. k3, k4, k5, etc. Now it is asking that the number of different Hamiltonian cycles in G is equal to. The number of different Hamiltonian cycles in G is equal to different. So please try to understand the number of different Hamiltonian cycles of length n. I would say the very first thing that the question should specify that Hamiltonian cycles of what length, because if we are not defining the length, then we will keep adding it. I mean, it's just a random question then, right? So please, the number of different Hamiltonian cycles of length n in G will be equals to what? So please try to understand that if I take this as a graph, then first of all, it's an undirected complete graph on n vertices, but it did not say whether the vertices are labeled or not. It did not say whether the vertices are labeled or not. So my very first question is, therefore, this is a question from GATE 2019. This is a question from GATE 2019, and the marks were allotted to all the students for this particular question. The marks were allotted to all these students for this particular question, because first thing, they did not specify that whether you are asking for the cycles of length n or something else, because if the cycles of maybe of any length, then none of this is a correct answer. Apart from that, they did not specify whether the vertices are labeled or unlabeled, because if vertices are unlabeled and if it is a complete graph with n vertices, if vertices are unlabeled and it is a complete graph with n vertices, then all the cycles of length n will be same. All the cycles of length n will be same, and in that case the answer will be 1. In that case the answer will be 1, that they are all similar. So though you are saying how many number of different Hamiltonian cycles, but different means what, right? So that's the idea. So that's the context, that even if you are choosing the different cycles of different length, then there will be some cycle of length 2, some cycle of length 3, some cycle of 3, 4, 5, etc. So 3 plus 4, 5, 6 plus 7 plus up to n. So 3 plus up to n does not satisfy any one of this solution. Therefore, there are some ambiguities, but the gate authorities were assuming that you will provide the answer in terms of number of cycles of length n when the vertices are labeled. So that's the actual question. Let G be an undirected complete graph on n vertices where n is greater than or equals to 2. If the vertices of the graphs are labeled, then the number of different Hamiltonian cycles of length n in the graph G will be what? That's what was expected from the question, but that's the logic. Anyway, leave it. So let's assume that these are the vertices A, B, C. Please tell me how many cycles are possible. Let me just give you one intuition, then you all know the solution for this, but let me just give you one intuition. If there are 3 vertices A, B, C, then how many different cycles are possible? Please try to understand. If I say A, B, C, A, it's one cycle. Now, does it make any difference if I start the cycle from B? Does it make any difference if I start the cycle from B? So this is same as if I say B, C, A and B. Yes or no? So these are the same things. Devins? No? No. So that's the idea, that these two are the same thing. But apart from that, if I'm saying after A I'll visit B, after B I'll visit C, or if I say after A I'll visit C, let's think that after A the next vertex is C, after C the next one is B, and after B I'll go back to A. So these are same or different? These are same or different? Please, if you guys have understood one simple concept of permutation and combination, that is circular permutation. How many necklaces can be, or how many different necklaces can be constructed out of n beads? How many different necklaces can be constructed out of n beads? So necklaces are circular, right? So the number of necklaces possible out of n beads will be n minus 1 factorial by 2. Why? Because, I mean, if let's try to understand that, let's assume that there are 3 color beads, red, green and blue. Red, green and blue. So you can arrange them in a rope in this particular manner, that green is on the right side of red, after green there is a blue color bead and then the red color. But please tell me, these two are same or different? These two are same or different? That's the very first thing. Why this divide by 2 is here? Why this divide by 2 is here? These two are same. Why? Because if these are the necklaces, then you can turn around the necklace. So if you turn around this particular thing, if you turn around this particular thing, then this two will become exactly same. This two will become exactly same. So that's the logic. If you eventually turn around, if you just flip it, if you just flip your necklace, then it will start looking like this, that this green color bead will come on the left hand side of the red color bead and this blue color bead will come on the right hand side of the red color bead. So these two are same. Therefore, because there are two patterns which are exactly same, therefore it has to be divided by 2. Therefore, it has to be divided by 2. Same is the case in this particular example, that these are just the cycles. They are not fitted somewhere, right? So these are just the cycles. You can view them from whichever angle you want, so just a same cycle, whether you watch it from the front side or if somebody is watching it from the opposite side, then it is the same cycle only. So to you it is appearing as in the clockwise it is appearing as CBA, and anti-clockwise it is appearing as CAB. The person who is looking it from the other side of the cycle will eventually see it as in the clockwise direction, he will see it as CAB, and in the anti-clockwise direction he will see it as CBA. So that's the idea, that these two are the same thing. Now, sir, this is when there is no difference between clockwise and anti-clockwise direction. When there is no difference between clockwise and anti-clockwise direction. So on a circular table, if you want to around a circular table, if you want to ensure that n people are sitting around the circular table, then how many ways n people can be arranged around a circular table? So people can be arranged only in n-1 factorial way. People can be arranged only in n-1 factorial way. Why? Because if the people are sitting over the chairs around a circular table, then you cannot turn them around and can see now who is on the left hand side and who is on the right hand side. You cannot do that, right? So when there is a distinction between clockwise and anti-clockwise, because you cannot see it from the other side, when there is a distinction between clockwise and anti-clockwise, then there will be n-1 factorial combinations. But when the clockwise and anti-clockwise are same, then it will become n-1 factorial by 2. It will become n-1 factorial by 2. So in context of beads, it will be n-1. In context of necklaces, it will be n-1 factorial by 2. If you are trying to arrange n people around a circular table, then the answer will be n-1 factorial. If you are trying to arrange n people in a row, the answer will be n factorial. Yes, all of this are there. Now the answer is quite simple. This is just related to the concept of permutation and combination. They are asking a question of graph theory, but the concept involved will be of permutation and combination, because these are the cycles of length n. So number of cycles of length n will be n-1 factorial by 2. Number of cycles will be n-1 factorial by 2. The logic is same, that it will be a cycle of length n. So you can, the different cycles which are possible are this. Why? Because there will be no distinction between clockwise cycle and anti-clockwise cycle. Clear? That's it. Simple enough. Now it's okay. So in this particular case, there are some modifications, and in 2019 the marks were allotted to all the students whosoever was appeared in GATE 2019. Let's look at this. This is the similar question. They asked this question in 2012. Now what will be the answer for this? Give me the answer for this question. Give me the answer for this question. Fast. Let G be a complete undirected graph on 6 vertices. Now this time they were they categorically said if vertices of G are labeled. So yeah, now we know that the answer cannot be 1. Now we know that the answer cannot be 1. So let G be a complete undirected graph on 6 vertices. So it's a complete graph on 6 vertices. Then the number of distinct cycles of length 4 in G will be what? Sir, to construct or to observe a cycle of length 4, there should be exactly 4 vertices. There cannot be 6 vertices. So out of this 6 vertices, let's assume the vertices in the complete graph K6 are A, B, C, D, E, F. Now, out of the 6 vertices, you can choose 4 vertices in how many ways? Sir, we can choose 4 out of 6 in 64 ways. So, what will be the value? So, 6, 5, 13 divided by 12. So, this will be 15. Right? So, you can choose 4 vertices out of 6 vertices in 64 ways. Now, please try to understand. This is a complete graph with 6 vertices, so all possible edges will be present if we choose A, B, C, D as 4 vertices out of the 6 vertices. Then all possible edges are present between this 4 vertices also. All possible edges are present between this 4 vertices also. Now, if these are the 4 vertices, how many cycles? Please try to understand. Sir, this is your A. Let me explain that what is the logic. So this is A, B, C, D. So this is one cycle. This one cycle, yes sir. After A, on the one side of A, we have a B, on another side of A, we have C, right? Now, another one is this. Please try to understand this. Sir, do you realize that in this particular case, on one side of A, we have B, on the other side of A, we have D. Clear? So, sir, with four vertices, how many cycles are possible? With four vertices, these are two. Sir, can you think of anyone else? Yes, sir. Yes, sir. We can think of one more. A, B, C, D. Now, if we have this particular cycle, then there's a different one. On one side of A, we have C. On the other side of, D. On one side of A, we have C. On the other side of A, we are having D. Yes or no? On one side of A, we have C. On the other side of A, we have D. Here CB are the neighbors of A. Here CD are the neighbors of A. Here BD are the neighbors of A. Can you do anything else? Can you have any situation in which the neighbors of A are other than this possible solutions? No, sir. So, with respect to 4, again the same logic, sir. When we are taking 4 vertices, the number of cycles will be 4 minus 1 factorial by 2. What, sir? What is 4 minus 1 factorial? It will be 3 factorial by 2. 3 factorial will be 6 by 2, and this will be 3 only. So, again same logic. That's what we have learned in the previous question. That if there are n vertices, then the number of cycles possible, if there are all possible edges, around between those n vertices, then the number of cycles will be n minus 1 factorial by 2. So, if we are taking 4 vertices, then with respect to 4 vertices, the number of cycles will be 4 minus 1 factorial by 2. But the idea is, among these 6 vertices, which 4 you are choosing is important. So, you can choose 4 out of 6 in 64 ways, that is 15, and for each combination of 4 vertices, there will be 3 different cycles. Therefore, 45 will be the answer. Clear? Who said 30? Devin's review. Is it clear that there will be 45 cycles, not 30? Why? Because you can choose 4 vertices out of 6 in 64 ways, that is in 15 ways you can choose 4 different vertices, and when you have 4 vertices with one combination of 4 vertices, there are 3 cycles. So for 15 different combinations, there will be 3 cycles, and the ultimate answer will be 45. Clear? So that's the idea. Now please try to understand. If I make this graph as a directed graph, then what will be the answer? In the equation, if it is given as that, let G be a complete directed graph. Complete and directed. This itself is ambiguous. So basically, there will be complete directed. So there will be 2 different edges between a pair of vertex, because this should be complete in this direction also. This should be complete in this direction also. Right? So if the edges are directed, and if the edges are present in both the ways, then the answer will become 90. Because if there is a direction of the edge, then clockwise will be different from anti-clockwise. Because if you say A, C, if this is one thing, and if I simply, let me just put it in another way, from the opposite side it will look like what? From the opposite side it will be A, the C will go this way, this will be B, this will be D, so it will look something like this, right? So there's an edge. So that's the idea. It will start looking like this. But the opposite, when you say A to C, so this is the same thing. This is the same thing. But the idea is these two are same. These two are same. But this is a different one, because in that particular case there will be an edge from C to A. So in one case you are going from A to C, in another case you are going from C to A, therefore number of cycles will double. So please make sure this answer 91. Yes, Devins, right? So this is it. So these are some things which you need to ensure, that graph theory concept can also be, the questions of graph theory can also be combined with aptitude. So a lot of aptitude is involved, because the concepts of graph theory are very limited, but there are number of questions in the GATE exam from this particular chapter, graph theory, and most of the time they will utilize the concept of aptitude one way or another in order to formulate a good quality question. So this is it. That will be all for this particular session. Thank you very much for joining this session. This is my Telegram group. If you guys have any doubt, then you can ask me here. Thank you very much for joining this session. Take care. Keep learning. Have a very good day. Thank you very much.